Hello, and welcome to another of PAVE's weekly virtual discussions. I'm Ed Niedermeyer. I am the Communications Director for Partners for Automated Vehicle Education. And today we have a topic that we've been wanting to get to for a while. There's just so much in this space to discuss, and this is a really important one. This will also not be our last discussion on this topic because there's so much to cover. So today's topic is mapping and the importance of mapping, why maps matter. Both to autonomous vehicles, but also we want to discuss sort of why they matter to the larger mobility ecosystem, because I think it's really important to understand that in order to understand how AVs will affect it and be affected by it. So we have a wonderful group of guests here today to help explain this really interesting topic. First, from Carmera, we have the founder and CEO, Gupta. Welcome.
Thanks for having me.
From National League of Cities, Brittney Kohler. Welcome, Brittney.
Thanks.
And from INRIX, we have Avery making his second appearance on a PAVE panel.
Thanks, Ed.
All right. Well, thank you all so much for being here. Let's go ahead and start off with some technical insight. I think it's really important, since we want to discuss sort of the broader context of why this matters. Let's understand what HD mapping for autonomous vehicles means. Obviously, we as humans understand what maps are, and we use them for navigation almost entirely. But in the context of AV maps, there's a lot more that maps do for an automated driving system. So, Ro, why don't you give us a little bit of a rundown on sort of what AV maps do on a technical level?
Sure. This actually happened to coincide with an event that's coming up, which is very relevant to the topic of why maps matter, that we're going to be doing with McKinsey soon. And so actually we decided to take the opportunity to show just a little sneak preview of some of the content from that kind of white paper we're doing. Because also maps are a very visual sort of concept. And so hopefully this will help understand kind of the general premise of why maps matter, and particularly on the technical side. So as Ed said, first off, just at Carmera, we build high definition maps for autonomous driving. We especially focus on the dynamic element, keeping maps up to date, which is a very difficult problem. But this is an example of an HD map. In this case, it's for a level 4 robotaxi customer. But as Ed said, in the upper left is what we humans would see, but in the main background there is what the machine sees, and that's what these maps are for. They're for the machine, not really for the humans, although as we can discuss later, there are some really interesting byproducts for humans as well. But to start off, before getting too much into the technical reasons for mapping, it's also important to note, and it's something that we'll actually get into even more in this upcoming event I mentioned, and a little bit I think in this panel today as well, that there's actually a much more sort of holistic scope of the impact of maps for autonomous driving. It starts with sort of core safety and user experience needs, which I'll go into a little bit of detail on. But there's actually, as we sort of call it, it's kind of a take on the Maslow hierarchy, but the mapping hierarchy of needs. There's a number of other benefits that having very accurate, fresh maps support. And so I think, sort of from a systems thinking perspective, there's a lot of stakeholders that take interest in this. But just to level set on the safety side, this is really what maps, have been kind of really focused on to date in terms of the early development for autonomous driving. And really that's because maps are a fundamental redundancy and sort of foresight layer for the 3 core questions that any autonomous system brain is always asking itself. So, where am I? Localization, what's around me, perception, and what do I do next? Planning. And for each of those questions, a good map can serve as a very trusted reference point or redundancy source to make sure you're answering those correctly and very efficiently. But as I said, there's more to it as well. And, there's still certainly a lot of work going on to really solidify the safety cases that all the autonomous driving developers, whether the traditional car companies or the full stack AV companies, However, what we have seen, especially in the beginning of this year, kind of the turn of the decade, is there's now a lot more focus moving up the pyramid, particularly now on user experience. And in our case, sort of a high fidelity, very fresh map actually has very direct linkages to different levels of user experience. So today, it's just, the map, basically the map and weather are essentially two of the biggest factors on whether the autonomous driving feature are even available at all. So that's, just the being able to actually turn that on in your vehicle is one baseline element of user experience. But now developers are looking ahead as well on smoothness of the ride. So for example, engagement or disengagement frequency or abruptness, also things like the optimal ride itself. So, are the ETAs still being maintained? Are they routing me the right way? And this is actually very timely. Actually, just the last JD Power technology UX study just came out about 10 days ago. And sure enough, people are starting to get more educated on these autonomous driving features and even, buying them beginning in the luxury markets. But they're also, we're seeing real data on how big a factor user experience is in understanding the value of these, and both kind of what people really like and also what people find really annoying or distracting or confusing in terms of how these systems engage. And so for that reason, actually one of the top leaders here is Cadillac. And actually we received permission from Cadillac, from GM, to share this with you. This is a list that they've come up with. They're really one of the creators of autonomous driving features in production, privately owned vehicles with Cadillac Super Cruise initially, and also one of the pioneers in using high definition maps at large continental scale for that. And so for both the safety and the user experience reasons I mentioned, this is sort of their list of 11 reasons why maps matter so much. First off, they say we should think of HD maps as a sensor, not just data. So a lot of people call it the fourth sensor, so to speak, or the third sensor. So first reason is they have the longest range of detection of any sensor, right? So a map can see miles and miles ahead or around a corner. They're the most accurate, especially if you're using LiDAR-based maps that can really get down to centimeter level accuracy. And of course, that assumes that they're maintained and kept up to date when things change. They are able to detect certain road features other sensors can't. They are able to also sort of predetermine a smooth arc for curves, which again, going back to the smooth UX hierarchy that we just showed you, is very important. They are, as I mentioned this before, they are or should be frequently enhanced, meaning through regular map updates. Again, that's where our particular company is really focused. They are used to geofence the autonomous vehicles so that the user knows when that autonomous driving feature is available or not available. We already mentioned they're a big part of localization so that the vehicle can reference the map to really be sure it's snapped into the right place in the world. They are able to relay unmarked patterns or rules. So for example, virtual lines that go through an intersection that wouldn't be in the paint. They're able to tell you correlations between things, especially down to the lane level. They're not impacted by weather. And again, fundamentally, they are the safety layer for an autonomous system and one of the most reliable sources of truth to verify that the live sensors are doing their job correctly. So I'm going to pause there. I was trying to go quickly because I want to make sure we get to some of the other folks and some good discussion. But first off, thanks to Dave Craig at GM for allowing us to share that. And as I said, this is part of a much larger, more holistic sort of concept of the hierarchy of needs, so to speak. And we can plug that later, but if you're interested, we'll be deep diving on that in the coming weeks. Thanks.
Yeah, thank you so much, Ro. That was just a really awesome, comprehensive overview of sort of the main question in terms of AVs, like why do these maps matter? And I think especially when you think about how complex autonomous driving is, the ability to sort of create sort of some consistency around what we know is sort of fixed in the world reduces that complexity. And so I think on that level, it's also really easy to understand. Avery, I wanted to ask you sort of, INRIX is not a mapping company itself per se, but you guys generate a lot of data that goes into maps. What are some of the kinds of data that go into maps, maybe on a fundamental level, and then sort of additionally, what else can be sort of worked into maps?
Yeah, and I mean, the way that INRIX has thought about our business of data for a long time, and we are agnostic to the type of map as you or I might think of it, the location of roadways, and more about how do you layer data on top of a map that makes it more useful historically for a human driver, and now as we start to think about automated driving systems for an automated vehicle. I think one of the points that's worth unpacking a little bit, and I like the hierarchy that Ro had shared there. There's a lot of different ways to think about that stack of an HD map. The kind of hierarchy of needs is a great way to look at it. You can also look at it though as data layers. The visualization that Ro had showed highlights that geometric version, which is how, when a lot of people think about an HD map, if they've heard of it, that's the first image that pops into mind. Ah, cool, it's the representation in the physical world of where things are. But there's a lot more to an HD map than just, this is the location of, these are objects at these locations. It also includes that semantic information that Ro touched on at the end, where it's actually taking an object and converting it into an understanding. So an 8-sided metal object is a stop sign. Well, what does that mean? What do I need to do as a vehicle? It's not enough to just know the location and shape of that object. So you've got that semantic layer that talks about how do I interpret the world around me. You then have the priors level. So you can talk about what is this vehicle seen in the past? How does it perform? And as it's encountered this intersection, it tends to see a higher likelihood of X. Therefore, I should bring into my planning process Y. And then real-time information, which is where INRIX has historically played as well. So things like real-time traffic or incidents or road weather, bringing in that real-time component to the physical structure of the roadway. Before kind of kicking it over to Brittney, I think it's really maybe useful to think about how INRIX first got involved in the AV mapping space with our road rules project. So taking a look at this kind of stack of data, talking to multiple vehicle operators about their challenges and their progress building and leveraging HD mapping products, and identifying one of the data gaps within that semantic layer that was a challenge, which is establishing ground truth understanding of what the rules and restrictions set by the public sector are that vehicle needs to abide by. So in the absence of a digital record of that for cities, states, and road authorities, each individual vehicle operator or mapping provider is having to build that data set themselves, validate it. It's a huge time-consuming, resource-consuming process, and it ultimately doesn't get to the that end goal of the road authority actually validating what the rules are. It's a third-party validating. So we've got a basic platform for cities to kind of create that digital rules layer, one very small data component of what goes into a broader HD map. But I think that kind of opens the conversation, Brittney, to a lot of the work that cities are thinking about, which is, as we think about HD maps more broadly, even than just AVs, as layers and layers of data, where are the places that cities can be leveraging existing work around HD mapping and or participating in that process to provide a better product and ultimately improve safety for road users, including but broader than automated vehicles?
What a great tee up. I appreciate that, Avery. The National League of Cities and all of our cities and towns have been talking about the mapping world as part of our not only city function, but city future. And a lot of what we're seeing in the autonomous vehicle space is really pushing the edge of where we've been as we've embraced new styles of data layering, new styles of mapping. And I think a lot of the questions right now are really questioning the core of the future of what's available from an open source perspective, what's available that can collaboratively add to the information that is available to any operator who wants to be in our cities and doing business with us. And we've seen tremendous movement to collaborate across city lines as well. As many of you have probably been following, the mobility data specification led by LA, and other elements of shared and open rules of the road, as Avery mentioned, are all starting to be digitized and changed so that they're responsive to the platforms that autonomous vehicle manufacturers are using today. And hopefully, we'll continue to advance these conversations in a way that brings together the public sector and the public need for what these these data layers can accomplish for cities, and most importantly for those users and our neighbors, and really take that to the next level of how does that advance transportation and make it more seamless, more energy efficient, and frankly just better all around for our nation, and hopefully for our economy as well, as we add additional benefits to this. So we're excited about the potential here and believe that there's a lot of collaboration between the work that that our folks here on the line are doing, and hopefully those who are also participating and listening in.
Yeah, so I want to go back to Roe in just a second and ask him a little bit about the different approaches to mapping in terms of actually collecting the physical data that's out there. But Brittney, really quick, we have a question from the audience from WGI. Are there ways to develop infrastructure for cities that is more readable by mapping fleets? And again, we'll get to Roe in just a second, where he'll talk about some of those fleets and approaches. But yeah, this is something the audience was curious about. I was wondering if
this has been a question out there for a while, is whether the infrastructure needs to change to the new technology being put on it, or whether the new technology is going to need to be able to read. My guess is that it's going to be both. We're going to need to meet each other where we're at. Every pothole is not going to be covered so that it's a perfect ride, right? But at the same time, identifying where that pothole is a really important element of building that system back up and making it better. And so that's where we've seen some initial piloting and collaborations that have been really interesting. But ultimately, I would say we should be talking through our technical associations around what those standards are. There's been some work with the national MUTCD discussions. If you're not familiar with those, it's really the devices and technical specifications for roads and what goes on there. I think there's much more we could do to streamline this by setting a few specifications early and really making those the building blocks. And I've been really impressed by some of the work to really use common language and common terminology, and through that common sort of elements that can help us get over the stumbling block of each item being proprietary, and hopefully help us move that forward.
Yeah, absolutely. I think that reflects a lot of the challenges in this space. No, and Avery, I was just going to mention again the AV rules of the road, because I think that's sort of intended as to be a way that cities can help build sort of digital infrastructure that makes maps better, rather than having
I mean, it's a super basic concept, right? Like, we're not recreating HD maps. We're not going to, fundamentally advance the science of automated vehicle operation. It's more of, here's one data set that cities could do a better job of providing digitally, and here's a framework to do it in a way that makes sense for vehicle operators. On the question, to the question from the audience, though, around kind of infrastructure versus physical versus virtual infrastructure, I think there is a risk of kind of looking at a challenge of, let's take rules of the road for vehicles trying to identify stop signs or speed limits, and thinking about it under in the frame of, okay, well, how do we make physical signs better and more easily readable for a sensor suite on an automated driving system? Whereas there may be an easier solution that's simply, why don't I deliver that in a digital format that actually works better and is cheaper and much more lightweight for all parties? So I want to make sure we're not just kind of putting additional layers of complexity onto, well, we've done things like this for 100 years, so let's find ways to, embed things into road paint and to put QR codes hidden on stop signs as the solution. It may be in some cases, but I think kind of trying to boil it down to its lowest common denominator of, well, what does the vehicle need? Well, just tell me what the speed limit is on this roadway. Okay, well, I can do that digitally. I don't need to do that using expensive physical infrastructure.
Yeah, absolutely. And you both brought up some really fascinating stuff that I want to get back to, but Ro, let's go to you really quick. We've just been talking about sort of the advantages of sort of aligning things, but mapping is a really diverse space. Can you just explain a little bit sort of some of the different approaches that are taken to mapping? I know some are on board, some you have dedicated fleets, there's hybrids. Obviously you have a company in this space, maybe you'll have a few biases about what's better or what's worse, but if you could share maybe some of the advantages and
Sure.
challenges of some of these different
approaches. The only thing I'll say to that last question is a very short statement, which is fresh paint is like 70% of the problem.
Okay, that's great. Yeah.
Like on lanes and signs. Anyway, but to answer your question, Ed, yeah, it's a much longer topic, but to summarize, basically maps, as Avery was mentioning, maps happen in layers. Any map, really, they're layers upon layers upon layers. So, like, question is, how do you build those layers to serve the purpose? And in this case, we're talking about one of the highest demand, like the most demanding use case you can imagine, automotive grade, production use, right, for critical safety and features. So, but then the other question is, how do you get to that quality at the scale and cost that would make it feasible? And so our approach to that is there's existing techniques that come out from the surveying world and kind of the older generation mapping world that have proven to be fairly effective, especially at mapping like continental scale highways, and that's also starting to go down to other road classes as well. But there are a couple limitations with that. It's costly to do, and at a certain order of magnitude of road miles, it becomes a little bit harder to pay for, for like when you're talking about like all the roads in the world, when you go from hundreds of thousands to millions of miles of road. But even then, you could still make a case that that's feasible to map all those roads once using the so-called older surveying techniques. That still doesn't solve the problem of keeping them up to date. You can't just keep running LiDAR survey vehicles all over the place all the time, right? Even if you're Google. And so that's really the key unsolved problem. And there's a number of thoughts about how to do that. In our case, we believe we need to take a very agnostic approach and not assume too much about what sensors will be out there ubiquitously and which costs will go up or down or what have you. So we've taken the approach of, first off, being very hardware and ecosystem agnostic. We don't sell hardware or cameras or chips, and we think that's really important. We think, in fact, the auto industry really, really desires that they don't want to feel locked into any one piece of, a camera or hardware or chip or whatever it is. And so you should be able to aggregate sensor data, particularly camera data, from really anywhere to help update these maps. And then that's actually, I just sort of mentioned the other element of our approach, which is assuming really the magical sensor that has, is able to see a lot of detail, is, you can assume will and pretty much is on every new car rolling off the production line. And is very cheap, and there's a lot of technology around, is cameras. So LiDAR, if LiDARs are on every vehicle one day, great, but no one's assuming that. Radars can be somewhat useful, but they just don't have the same sort of fidelity and density of optics that a camera does. So sort of a crowdsourced camera-based approach that is agnostic to which device it's coming from, we think is really the key to making that dynamic layer of map maintenance scalable. So I'll end it there. There's a lot of other topics where you can start talking about where things like satellite data and aerial, et cetera, can work its way in, edge processing versus cloud processing, but it's a longer conversation.
And just really quick, we are talking about HD maps, generally speaking here. Like, what does that mean? Like, what is everyone knows, like, 1080p, right? That means you have HD screen. Is there a line in which a map becomes HD? What level of precision does that happen at?
Yeah, at one point we were thinking about, do we need to like brand something 4K maps or something? But no, I think the issue is that the terms actually have become pretty fuzzy. As we know, also with like levels of automation and everything, people use them differently. I would say generally though, in terms of HD, I think people have converged to an absolute accuracy, spatial accuracy in the tens of centimeters, but that we've seen pretty wide variation all the way to the lower part close to 10, all the way up to just, just barely sub-meter accuracy. And then there's another element of accuracy, which is relative accuracy. So even if on absolute terms in the earth, your error is X, within the sort of map, frame that you're in, you also need to make sure that objects have relative accuracy that are even better than that, say 10 to 90 centimeter range. Usually you want to get down below 10 centimeters for relative accuracy, closer to 1, 2, 3. So that's on an accuracy level. And then the other kind of aspect of what's HD versus SD, which would be standard definition maps, is typically just the features you find in it. In your standard definition human nav map, you don't really need all the lane level detail and every transformer box and pole that, these cars are localizing themselves on. But in an HD map, those are part of the requirements.
Yeah. So again, lots of diversity on the technical side and the different approaches and even applications. But Brittney, Seattle DOT had another great question, which you were sort of, I think, getting towards a little bit in your previous comment, which is sort of, where are we at with the problem of aligning sort of these various mapping efforts? You mentioned sort of the need for a standard and language. So it sounds like we're in the early stages of that. They asked us in the context of road closure data specifically. Avery, maybe you have something to add, but on that, but Brittney.
So road closure data and management of the systems has been a really key element of how do we get that information out more quickly and in a standard format. And I think a lot of state DOTs are also working on that from their perspective as well. But one of the things that I think is really standing out to me in this conversation is the role of maintenance and being able to do clear-cut maintenance calls and things like that in a really strategic way. And whether that's a temporary road closure or a delivery pickup, there's a lot of context for sharing information like that. And I think there's a lot of businesses that would love to know how that works. And I've heard several of the logistics companies really ask for that level of information. And maybe that's another area to really expand more of these conversations on.
Yeah. I mean, on work zone specific and road closure specifically, I mean, that's one of the places where I think it's really clear where there is some foundational catch-up work that needs to be done first before you can get to wouldn't it be great if we could share in real time X. And a lot of the way that work zones and road closures are communicated now is either a physical map with some lines, some highlights of what's going to be closed, or a spreadsheet that's sent out periodically to a list of mapping stakeholders to then manually include in their own process. In some instances, that might be published in like a GIS format. Whether or not that's managed and kept fresh, I think has been a challenge. So a quick shout out for US DOT's work zone digitization project that they have underway. That is really a first step, and it's admittedly a relatively small first step toward creating a common specification for communicating out work zones. A really basic concept. It just requires that we all get on the same page about how we're going to communicate that out, have a process in place to manage that information. But it sounds like a small step, but until you take that step, it's really hard to do all the other components of, well, I want to own and manage my own HD map at scale, and we're going to have interoperability across jurisdictions for HD mapping. Like that might happen, but we can't have that until we have some of these fundamental, how do we handle basic digitization and sharing of said data by the public sector?
Yeah, absolutely. So I really loved Ro's hierarchy of needs, because it just shows all the different ways that maps can benefit AVs, from safety to user experience. I want to sort of take that framework and just as we close out here, sort of apply it to the broader ecosystem. Sort of what can HD maps do to help cities, right? We asked how cities can help sort of contribute to HD mapping efforts. How can HD maps help cities, and maybe potentially AVs are part of that, or might potentially be part of that. Brittney, let's start with you, and then we'll go from there.
I think that what we would love to see is really a problem-solving relationship with some of these mapping tools, and I think we're willing to do what we can on our side to be responsive to meet those goals. But sometimes it's the data set on the other side matched with our ability to gather and collect information and do that in an anonymized manner, that really can make the difference between an improvement or just the status quo. And so I think we'll be looking forward to having more and more of those conversations around what the mapping can bring and how public partners can benefit from public maps.
Yeah, and I'm sorry, I forgot to add sort of one of the questions around this was brought up by the League of American Bicyclists. They point out that there's just very few high quality inventories of sidewalks and bike lanes. And I was just having another conversation that came up as well, that just basic data about how bikes are used. And so that seems like something that could be a really valuable addition to this. Avery?
Yeah, I mean, and even where there are inventories, they're not easily consumable and shareable and digestible by constituents, but certainly not by automated driving systems and other new mobility players. So I mean, I think that's where the bidirectionality of data exchange, it's not the HD map itself, it's the process of a city being able to more effectively push out critical information, or at least valuable information, to end users, be they automated driving systems or human drivers, connected human drivers, and then the ability for the process of generating and building an HD map to serve as a data input for cities of anything from road quality to curb usage, to make better and more effective planning decisions. I mean, that to me is the big value prop here, is better exchange of data, which is outside the scope of what most people think of as HD maps, but to me is going to be the primary byproduct here.
Yeah.
Well, I was just going to add, I mean, I agree with everything that Brittney and Avery said, and on the bidirectionality, that's sort of the, kind of the holy grail. But I would just add to that, I think it's incumbent really even more so on the private sector, companies like INRIX and us, to take the first steps and catalyze it and really arm cities, because, we often can move faster. We often do have the tools to be able to do it. Like in our case, for example, we are actually providing the city of New York with work zone, real-time work zone information around the city. Like, all the consumer maps, Google, et cetera, only have, we estimate, anywhere from only 10% to 30% of the actual work zones going around in the city that we're seeing. And of course, as Avery said, oftentimes they don't align with the records that the city themselves has. So they're very appreciative. And they've talked about, they would like to also make that a feedback loop, bidirectional feedback loop, but someone has to start it. And I think it is up to companies like us to be the first.
Yeah.
Great. Well, this has been fascinating. If frustrating to try and keep into 30 minutes, but as I said, this is just our first discussion about this. I think there have already been numerous parts of this conversation that we could easily, spin into a much deeper conversation. I think especially when it comes to this public-private partnership issues, we're seeing that be a big topic with mobility data standard, which you, Brittney, mentioned, and is really focused on micromobility, but has potentially big impacts for AVs and in this space as well. So look for many more of these kinds of conversations about this really important and interesting topic. And huge thank you to our guests today for being here and sharing all of their wisdom and experience. Gupta, thank you so much for coming.
Thanks, Ed.
Great.
Brittney.
Great. Thanks, guys. It was a blast.
Thank you. And Avery Ash. Thank you all.
All right.
And thank you to our audience as well for making the time for another of PAVE's weekly virtual discussions. We have a whole host of panels in September around education for back to school. I'm extremely excited about those. And we really hope that you are as well, and that we will see you there. Thank you.